Good evening, Mr. Shand.
Good night, students. I'm going to encourage you to just send out a blast in the WhatsApp. I'm starting at 7:15 tonight. We have lots of work to do. I hope that today was a good day for you. In another 8 minutes, I'm going to begin. Can't wait until 7:30. Starting at 7:15 tonight. Thank you. All right, students, how are you today?
Okay.
All right. I gave you a homework question. Were you able to do it?
I didn't remember about the homework.
All right, can I start it now for me, please? Start it now. Let us get it out of the way so I can move into something else. I'm going to ask you to start it now for me, all of you. If it is that you have not done it, there are 6 of you here. Let us get it going. Oliver, did you do the work?
Which one was the homework, sir?
Look at the bottom of the thing that I sent you.
You sent us something? When?
Don't tell me if I didn't send it
No, you didn't.
today. At the end of the last class,
You
or the
sent
morning of the
WhatsApp group?
in the WhatsApp group. Yeah.
No.
Mm. Mm. I clearly copied this stuff from the 10th. I'm looking to my what I call my snap file. I did something from the 10th at 7, the 10th at 8:23. Not the 10th, sorry, the 20th at 8:23. When was our last class? Was our last class the 19th? Yep. I created a file for you the morning after at 8:23 a.m. And
You sent it in the WhatsApp group,
not
sir?
send it. So let me send it now. But nonetheless, what I do, Oliver, unmute for me now, please. Hello?
Sir.
Is he hearing me?
Yes, sir, I'm hearing you.
Hold on a minute, please. Aston, can you say something, please?
Say that again, sir?
Okay, right, good. I'm hearing you now. Is Oliver on?
Yes, he is.
Oliver, can you hear? No, it's not on.
He is. He's on as SAMC.
Okay.
Sorry, this people are not hearing you.
No, I'm actually trying to send a document that I promised from last class.
Okay.
So I was trying to get Oliver's attention because he was the one who asked me if I could send it off tonight, and I said to him either tonight or tomorrow morning. So I was gonna say to him, if he didn't see it, we could have dropped a message in the group, man, and said, boy, sure, I don't see it. But I had done the document. So that's why when I asked for the homework, you were asking what homework. All right. So let me send this off. There's a question in it that I want you to do for me. Matter of fact, you know what? Do that question in your free time. I need to move. I'm going to send a document off, but I need to move. I recognize that I've been rather very patient, and this is now November, so I'm behind, and I'm going to be losing next Thursday because oh yeah. All right, hold on a minute, please. Let me share this screen. All right, so we're on to differentiation. And what we did last class was our first principle differentiation. Now, towards the end of the class, we got better at it, where it is that, remember, we use a formula, a limit as h tends to 0 of f of x plus h minus f of x all over h. And every time, in order to get our f of x plus h, which is our incremental change, the plus h that is, every time we see an x in the function, we're going to be adding our h to it and perform the operations accordingly. So if we have x squared, it's now going to become x plus h all squared. And then we have to go ahead and use our factorization or expansion to distribute the x plus h over the x plus h. Not yet. The x plus h over the x plus h. And then we do our calculation like that. And remember that when it is that
are you sharing screen?
Not yet. I'm reviewing what it is that we did last week. So what we did, when we would have done all of that, then we are going to be canceling out all of our f of x from our f of x plus h. At which point in time, we should be left with only terms containing h. And then when we factor the h, then the h in the denominator will cancel, leaving whatever h that is there when the function goes to 0 will be eliminated, and what is left is going to be your differential. Does that sound like what we did last time?
Sound like it, yes.
All right, I think so. All right, so now I'm going to be sharing my screen because I'm going to be moving into our differentiation and our rules for differentiation. All right, let me save this in 2 more seconds. Send the document back to this one. All right. You should see the you should see the document now from last week in the stuff. Are you see my document? My share document?
Yes, sir.
Yes, sir.
All right. Okay. So there are several rules for differentiation. There are several rules for differentiation, and we need to see how many of the rules we can cover today. Now, is anyone in the class wearing a necklace at this point in time? Anyone in the class wearing a necklace?
No, sir. Not me.
Not I.
All right. All right. So you all know what it looks like. Can you describe how it looks?
Having
Any one of them, whichever
things.
one you have. Go again?
Having
It's a
different
value
things.
going around.
What do you recognize from one of those things to the other thing?
One of, I said link,
The
sir.
link, right. No. I said one of those things. So I'm asking you, what do you recognize with one of those stuff?
They connect.
Okay. And describe it, not Jesus. Not because I'm not
Different
I can't
links
use the
coming
words.
together. Different links coming together
It's
to make
continuous
one.
and it's continuous and it has links.
And it's continuous. They
Excellent.
are linked to each
Thank
other.
Thank you very much. Right. So I have to squeeze it out of one, no? Jesus. But that's correct. So so I can have a necklace or a chain with many different links. If your neck is big, you may want a large necklace. If you have a small neck, you may want a medium or a small necklace. All right. So that's what the chain looks like. Now, the chain rule for differentiation is very similar. So for the chain rule, I can have one term, I can have two terms, I can have three, four, any number of terms. And once I'm using a chain rule, it means that I'm differentiating individual links. I'm differentiating individual links. So one link I'm differentiating, put it down. Then I differentiate the other link, put it down. Then I differentiate one more link, I put it down. And I'll continue my differentiation just like that until all the links have been differentiated. All right? Now the rule for differentiation, as it says here, y is equals to x to the n. Y is equals to x to the n. I'm differentiating y with respect to x. Now y is the equation. That is going to be my dependent variable, and my x is going to be the independent variable. So whatever x does, y depends on it. So I have my dependent variable equals to a function in x. Therefore, I'm differentiating y with respect to x. So I'm differentiating the function because I want to see what is the rate of change of one variable when compared to the other variable. All right? So in order to use my differentiation, I am going to, if you look at the screen, I am going to say that power n, y is equal to x to the n, that power, that exponent, that index, is now going to be used as a coefficient of x. So I'm going to take that down to multiply by x, and then I'm going to reduce the power by 1. So it now becomes nx to the n minus 1. Nx to the n minus 1. So as I have it in the notes, the power becomes a coefficient, and the power is now reduced by 1. The power becomes a coefficient, and it is now reduced by 1. All right? So I'm just looking at the naming of the functions just now before we get into the nitty-gritty of our differentiation. F of x is equals to y. So a lot of students say, me not like f of x, you know. But if you give them a function, y equals 2x squared plus 5x plus 6, then can work it. But the moment you say f of x is equals to 2x squared plus 5, so we can't work f of x or f of x hard. But f of x is really y. So nobody knows why I call Aston AC. She knows why I call her AC without even telling her why I call her AC. All right? But she knows because she knows what the C stands for. Right? But I can come to class and I can say afternoon, and then she knows who I'm talking about. And if I say AC, she also knows who I'm talking about. And then she may have another pet name that is attached to her by another family member. Her mom may call her another name different from her dad. Her dad may call her Pumpkin. Her mom may call her something else. So she may have different aliases, but guess what? It's the same person. Same person. Same person. One alias is f of x, another one is y. So don't be alarmed. I can give you my function in f of x. So when I say f of x, is not necessarily f of x. I can use h of x, g of x, p of x, r of x, q of x, whichever it is. All right? And all of those will still be equals to y. All right? Now, f dash of x is my first differentiation with respect to f of x. My f dash of x is my first differentiation with respect to f of x. Or if I have y, when I have my first differentiation, I'm going to have dy by dx, the rate of change of y with respect to x. My second differential, or my second derivative, same difference. I can speak of a second derivative, or I can speak of a second differential. All right? The second differential with respect to f of x is going to be f double dash of x. F double dash of x. And the second differential with respect to y would be d squared y by dx squared. And it goes on and on. If I want to find the fifth derivative, I could have f superscript 5 of x, or d to the fifth y over dx to the fifth. All right? Your syllabus asks us to go up to the third. So you won't get a question to evaluate outside of the third differential. Anything outside of that would be unfair to you. All right? Any questions so far with the naming of my function?
Not yet.
Not yet.
Any questions as it relates to the naming of my functions and the rule for differentiation?
Not yet.
Go on, pre-war, go on, sir.
Sir, can you re-explain what the dy over dx equal nx, what you were saying regarding that, please?
All right, are you guys hearing me now?
Yes, sir.
Sir.
Are you all hearing me now? I was reconnecting just now.
Sir, we've been hearing you.
Hello?
Yes,
Are
sir,
you
we
not
hear him.
hearing us?
All right, hold on.
Yes, you're not hearing us.
All right. Hello?
Yes, sir.
Sir, I'm hearing this. We're hearing this, sir.
All right, thanks. Yeah, but I wouldn't know if you didn't answer just now, but thanks.
Sorry.
All
No,
right.
man,
All right.
they
Is
answered.
it that you
They
were not
answered to the
hearing
hearing.
us?
I wasn't
Sir,
hearing you at all.
Okay.
I was.
Wasn't hearing none at all. So I was asking the question over and over, and then my phone started to reconnect.
Oh, you answered each time. Nicole wanted you to go over the one at the top.
Which one of them? The y equals x to the n?
Yeah.
Oh, okay, no problem. I wasn't hearing you at all, Nikki. All right, so y equals x to the n is just a formula. It's a formula for differentiation. Now remember what it is that we did last time around was to look at the first principles differentiation. The formula for the first principles differentiation is the limit as h tends to 0 of f of x plus h minus f of x all over h. That's the first principles formula. When you're using differentiation using the calculations method, y is going to be equal to x to the n, x raised to the n power. So therefore dy by dx is going to be equal to n x to the n minus 1. What do? We are using the superscript, the n, the power, to multiply in front of the x. See it right here, so it now becomes the coefficient. And then I'm reducing the power by 1. So it now becomes n minus 1. So whenever you're differentiating, the power is going to be used to multiply the term, and then you're reducing the power by 1 every single time, barring none, every single time. Right? So what I'm also saying to you is that I have different formats of naming my function. So f of x is equal to y, and I was using the example that I call Astonel AC. She knows why I call her AC. She knows what the C stands for, right? And I guess the rest of you will know when I say AC who it is that I'm referring to. But somebody else who is not a part of the
Me
Martin,
drop on
You're
or
speaking
serve one
again.
coin.
Seems Benjamin one again.
P of x,
Sir,
R of x, Q of x, all of those are still equal to y because
Sir?
it is the same function I'm referencing. So all of the pet
Yeah.
names and the aliases that I'm talking about is still referring to Aston.
Sure.
All right? So what I'm saying to you here is if
Sure.
I'm using the function, someone is speaking?
Yeah, boy, sir, is like a chip out for like
All
a
right,
good
hold
90
on,
seconds.
because hold on. I'm having hold on, hold that thought, please. I think that's Oliver. Hold that thought, please. All right. Oliver, can you speak now for me, please? Let me see if I can hear you.
What I was saying was that for about 90 seconds you weren't being heard. So everything that
Yeah,
you said, all of that blew off. When I hear
yeah.
everything.
I don't know what is happening. Oh, I know what is happening. I know what is happening. What I've recognized is whenever we have heavy rains, there is a challenge with the internet access. I don't know if water gets into the fiber, whatever it is, but several times in class tonight I have been reconnected. So where I live, we've been having rain since last night into all of today. So I think there's something. Anybody else having any internet challenge? How are you today, Nikki, at work with the internet?
Had internet challenge at work. It's a regular intervals for us at work.
Oh, okay. Yeah, so I think that is it. But anyhow, so whenever you're not hearing me, you can just let it know and just put it in the chat like you're doing. So I apologize for that. Yeah, so what I'm saying to you though is when you look at the function, my f of x, I have different names that I can call it. You know, Jamaicans are the best in terms of naming things, because when you have diarrhea, what people say you have,
Yes.
In a belly?
running a belly. No, you ever seen anybody belly run it?
When you have diarrhea.
Yeah. But
Not
Jamaicans,
literally, but figuratively, you know.
yeah, go ahead.
Sure, but people belly run like Alice.
Leave Alice
People
alone.
comes out of
Eh?
this.
Leave Alice alone. Yeah, but that's what it is. So Jamaicans are just very dramatic. So if you go to United States and say to our pharmacist, excuse me, do you have anything for running belly? They may say, huh? Because they don't have a clue what you're talking about running belly. And if you say to them loose bowels, they may also have a challenge. But if you say diarrhea, they may say, oh yeah, Imodium or Pepto-Bismol or whatever it is.
Or you can say constant.
Yeah, they're not going to even understand that too. But guess what? Another thing is conjunctivitis. If somebody has conjunctivitis, what we tell people so we have
Pink eye.
pink eye. No, not pink eye, pinky eye.
Pink eye.
Right?
Oh,
Pinky
how
eye.
dare I?
Yeah, absolutely. So, we have a knack of naming things. We have a knack of naming something, right? If you are too dark in complexion, we them call you.
Black or shine.
Or blackie, don't.
Blacker.
Right. If you're
Blacky
if
pig.
you're if you're plump
Blocks,
in
them
weight,
call yourself blocks.
are blacks. All right. If you have a little bit more pounds than others, what them call you.
Fluffy.
Or
Bigs.
bigs, yeah. Or
Fatty.
yeah, man. So we just have a nice way of and sometimes a very dramatic way of naming things and people. So I'm saying to you, in mathematics, it's the same thing. So I don't have to always use y. I can change it up and call it f of x. But my f of x is equal to y. And sometimes they say, no, it's so boring. All of the questions have f of x. I'm going to change one and call it g of x. And I'm going to change another one and call it r of x and p of x. It's the same thing. They all mean y. All right? They all mean y. So if I'm using a function for argument's sake as f of x, when I'm finding the first derivative of the function, it is going to be denoted as f dash. Look at that dash. There's a superscript dash. Look at it. F dash of x. There's a superscript with a little stroke up top. That is used to represent the first derivative of f of x. If I use my function as y, my first derivative, the notation that I use for my first derivative of y is going to be dy by dx. It's going to be dy by dx. To find the second derivative using f dash, it's going to be f double dash. You see right up here? Two dashes. F double dash of x. F double dash of x. F double dash of x. And to find the second derivative using y, it's going to be called d squared y by dx squared. D squared y by dx squared. All right? So those are just some notations. So I was at the point earlier when the phone was reconnected asking now, are there any other questions? Nikki, I hope I answered your question. Are there any other questions regarding this?
Sir, right where your cursor is, those two strokes and the single stroke, what are those called?
The single stroke is for the first differential. The double stroke is for the second differential. If I have three strokes, what will it be for?
I didn't hear what you said. For
The
the
first,
first and second
the,
one.
the first stroke is for the first differential. The one with the double stroke is for the second differential. So I'm asking you now, what if I had three strokes up there, what would it be?
Third differential.
For the third differential, right? And in terms of y, the third differential would be d cubed y by dx cubed.
Okay. So you said our syllabus don't require us to go more than 3.
More than 3.
Okay.
Right? More than 3. However, I will give you functions, even x to the 10th, but you're not going to be required to differentiate it to the 10th power or the 10th minus 10th differential. You won't be asked to find a 10th differential, but you are going to be working with functions up to the third power. I mean, the 5th power, 6th power, 7th power, any number of powers. All right? Okay, so with that said, let us look at another example. An example of what it is that we are doing. If I ask to differentiate x cubed, I didn't ask you to differentiate it on first principles. And remember, just some housekeeping matters here now. On Thursday, you'll be having your mid-semester test. I can say to you, differentiate this using first principle. If any of you use any other method than first principles, whether or not the answer is right, you are going to get 0 for the question because it means that you would not have followed the instruction. First principle is f of x plus h, the limit as h tends to 0 of f of x plus h minus f of x over h. When you differentiate in otherwise, you can go ahead and simply differentiate like I'm teaching you to do now. All right? But I'm going to ask you, please follow the instructions that are given. You must follow the instructions. So if I'm differentiating y equals x cubed, if you look carefully at the top of the page, in pink here, where it is that I have y is equal to x to the n, if you look at this, y equals x to the n resembles my function in example 1, y equals x cubed. True or false?
True, sir.
Yeah, man. So in that generalized form in pink up top, if y is equal to x to the n, therefore dy by dx is going to be equal to n x to the n minus 1. All right? Because I'm putting my power as my coefficient, and then I'm reducing the power by 1. So if I give you x cubed, y equals x cubed, when I'm finding dy by dx, what do you think my x cubed is going to become?
3y.
3,
Gonna be 3,
3x,
3 second power.
3x to the
3x.
second power.
Right, into the second power.
Very good, I hear you. Come, Nikki, finish your thoughts. You said 3x. 3x what, Nikki?
It's gonna be 3x and into the second power minus 2.
Yeah, so give me the thing. 3x to what number? Say 2.
Yes, sir. So the second power minus 2, 2.
Right, 2. So it's going to be 3x to the second power. And that's what it is. No, you tell me that's not easy.
So the first one always easy.
Yeah, absolutely. Always talk about that. All right, so this is it. So my dy by dx is going to be equal to 3. You notice I put my 3, look at blue. What I have in blue is just a partial answer, partial solution. I'm going to have my 3 there, and then I'm going to reduce the power by 1. So it's going to be 3 minus 1. And then, of course, 3 minus 1 is 2. Sir, whenever you work in the question, do you have to write the line there that you have in blue? I don't expect to see it. What I expect to see as calculus 1 students is that you move from the question y equals x cubed directly to the answer dy by dx is equal to 3x squared. I don't need anybody to write no middle term here, but you're not getting any point for it. At this stage, I want to see the question and then the solution. Y equals x cubed, dy by dx is equal to 3x squared. Any questions so far with that? Can you see what it is that I've done? Do you agree with it?
It look like the format you show we about, so
Very
we
good.
agree.
Very good. All right. So do me a favor now. You don't want to see that. I have something at the
All right.
tail of the page. I'm in the mute for 2 minutes. And I'm going to give you an opportunity to work that for me. I want you to find dy by dx of these. So when I say differentiate, it means that you're going to find dy by dx. Sometimes I don't have to use the word differentiate. I might just say find dy by dx. So I'll tell you, I'll go through different ways in which I could ask the question. All right. But in this particular case, you're supposed to find dy by dx. So I'm using for 2 minutes. And then I'll come back to you. Work it for me, please. That.
Mrs. something from limits, you know.
All right, sir. 2 minutes up, sir. It's the Shand.
Do I have a taker for the answer? What's the first link in that differential?
Sir, I'm
Minus 6x.
thinking that we need to find the first principle aspect.
No.
All right, we got the next thing.
Remember, only when the question says by using first principles, you use first principles. We have moved on now to the other aspect of differentiation, but we are now doing it the chain rule. First principles was last week. That's behind us. What's the first term? Oliver, you're saying something. What's the first term?
Minus 6x.
Very good. What's the second term?
Minus 2.
Hear this one now. What's the last term?
Hear this now. Minus 3 times x to the 0 power, which gets rid of it.
So it is what? When you say gets rid of it, it becomes what?
0.
0. Very good. Very good.
Becomes what, sir?
0.
Okay.
So here goes a rule now. One of the first rules within the rule that I'm giving you. The differential of a constant is equal to 0. The differential of a constant is equal to 0. So any constant at all I have that I differentiate, best believe that I'm going to get 0 for the answer. The differential of a constant is equal to 0 every single time. Not any other number, 0. And I will explain to you a little later. Oliver hinted at it just now, but I'll explain to you as we go along. So it's going to be, I'm rewriting the question just for explanation. You will not do this when I give you the question because I expect you to know that the differential of a constant is equal to 0. I'm doing this only for emphasis. So I'm rewriting the question and look to see what is in green. The constant -3 is really -3x raised to the 0 power. Anything raised to the 0 power is?
0.
No!
1, sir.
1! Numero uno. Anything raised to the 0 power is 1. Any something at all raised to the 0 power is 1. So me raising that x to the 0.
0 to the 3. 0 times minus.
0 times minus 3 is equal to 0, don't?
Yes.
So that's why the constant, when you differentiate the constant, it gets 0. Anything raised to the power 0 is 1. So me putting the x to the 0 there in green, not changing the story. It's not changing the story. Why? Because anything raised to the power 0 is 1. So look at what I'm doing, only for emphasis. You will not do this when you're doing the question, only for emphasis. The 2 is being used to multiply the -3 to give me -6 here. And I'm reducing the power by 1, so it becomes now 2 minus 1. The 1 up here is being used to multiply the -2 here to give me this -2. And I'm reducing this 1 by 1 each here. 0 is being used to multiply with -3, which gives me 0. I can stop it right there because 0 times anything is 0. So it don't matter what comes after it, it's 0. The differential of a constant is equal to 0 every single time. And then my final answer is going to be -6.
Sir, please go back over that again, please.
What is it that you're not seeing?
Sir, can you hear me?
I hear you, love and share, hon. I'm asking you, what is it that you're not seeing?
Yeah, what you are doing now, well, when you explain the two multiplying to thing with the 6 and the 1 reducing it to 1. Can you go back over that again, please?
Remember the rule for differentiation? Y is equals to x to the n. dy by dx is equals to n x to the n minus 1. So I'm using my n to multiply it. It becomes a coefficient. And then I'm reducing the power. So what I'm saying to you is that this 2 multiplied by this negative 3 is negative 6. Then I'm reducing the power by 1. I have to reduce the power by 1. That's the rule. So it becomes 2 minus 1. This one multiplied by negative 2 is negative 2, which is this negative 2. And I'm reducing the power by 1. So I'm going to have 1 minus 1 every single time. Every time you're doing it, you're reducing it by 1. And then this 0 is being multiplied by this negative 3 to give me 0. So 1 minus 1 is 0. Again, anything raised to the power of 0 is 1. So that is 1 times negative 2 is just simply negative 2. And 2 minus 1 is 1. So this is x to the first power. I don't have to write to the first power. I can just simply write it as x. So my dy by dx is going to be equal to negative 6x minus 2.
Sir, you know, I wrote the same thing because I remember you gave us this question. We wrote this question. That's how I was thinking the first principle because I know you love mix them.
And I deliberately do that AC. You know why? Because I wanted you to see that both methods actually give you the same result.
And then when I got the answer 6 minus 6x minus 2, I was saying, all right, x is raised to the power of 1. So I was gonna add it.
Right, as negative
But then
6x.
I'm saying no. So I just stop.
No, you're fine. And if you had even put it negative 6x to the first power minus 2, you'd have gotten the same number of marks, full marks. But just remember, I don't have to put it. I don't have to say 1x. I can simply say x. As a matter of fact, when I get to integration, I'm going to give you a stern warning. And if I see it on the exam paper or any other test papers, you're going to be penalized. When I get to integration, I'll speak more to you on that. Question. Are you okay so far?
So far.
So far, so good.
Sir.
Yes, mommy.
All right. So the negative 6 minus 6x minus 2. So what, the 2x minus the 6, the 2, the x minus from the x1, or the x missing. What did you do there?
We must have 1 minus 1, you know, which you get 0. X is 0 is 1.
Yes, because it's one x left here. So I'm thinking 1 x here, so it's negative 2 with the x minus x1 left, x1 x to the 1. So
Nicole, I think you're overthinking it.
hold on, let me put him at my earphone. I think I'm mixing up that
No,
part.
absolutely. Because the noise in the background is taking away the sound waves. So you're not fully hearing what the system is saying. You need to find another location, Nikki. The background is way too noisy.
Third question. You said if we use the first principle, when they ask us to differentiate, we'll get it incorrect. Is it a case where in all the time the responses will be the same
Back up.
with both principles?
Back up 1 minute. It's not that you'll get it wrong, you know. It's just that the first principles require so much more energy when compared to look at this question. You see
Yeah,
the
less
first question.
energy.
Yes.
But
So
I'm
remember,
saying
go ahead.
the outcome is usually the same. The response
Absolutely.
answer is usually the same.
Absolutely.
Okay. Right.
But get my foolish advice. If the man them say differentiate and them don't interrupt first principles there, don't use it. There's a reason. First principles can take you into 10 pages. And if you make one slight mistake, your final answers will be off. When it is that you do the
If they say simplify or find the value of y, and they don't say differentiate or first principles, what then?
Why are you overthinking it up now?
No, I'm not
All-
overthinking. I'm just asking. I don't know how the questions can be termed.
So what I'm saying to you,
Okay.
so once I don't use the term first principles, don't use it. There are different rules to the differentiation. I have the chain rule, I have the product rule, I have the quotient rule. I'm going to have the logarithmic function. I'm going to have the exponential. I'm going to have the what if I them? What if I them? When you see the rule, you will know what I'm talking about. And of course, you have first principles. When you see the rule, you will know what I'm talking about. That's what I'm saying. If it is not given, don't do it. But as we go further, you'll see that's what I'm talking about.
Okay, sir.
All right. So what I want you to do for me now is, like last class, we did a lot of questions. Tonight is going to be your night again. Example 3. Uh-oh. I don't want you to see my answers. Example 3. I did example 3 two ways. So that's why you see it on the left and the right hand side of the stuff. Start for me, please. No, man, I'm sound like I'm going to sleep, man. Let me fear. I'm sound like I'm going to sleep. Oliver, wake up. You finished to get the answer, Papa?
Yeah, man.
Nice. So tell me the answer, no, man. We're here for the answer.
You get 8x plus 3.
Anybody agrees with him?
Yes, sir.
Yes,
sir.
Anybody
Yes.
have anything different? Very nice, very nice. Anybody have anything different? Nikki, now, unmute, talk to me. What's the difference with the left-hand side calculation and the right-hand side calculation?
F of x versus h of x.
Very good. So one function I named as f of x, the other function I named h of x. Is my answer the same?
Yes, sir.
It's the same.
Yeah. Yeah. Man.
And if we have dy over dx, it's the same, right, sir?
Yes, ma'am.
Okay.
Talk to me. How you feel? Feel good? Hey.
Ish.
All right. I like when you say ish a while ago. You know why? Arsenal, please do not comment. Nikki, please do not. Where is
Sir,
Sabrina?
I was about to comment.
No, no, please do not. Please do not.
Mute
Please
back my
do.
mic.
Please do not comment.
Fine.
Because you're going to tell a lie now that I give the easy one in class and then give the easier one. All right, tell me. All right, tell me, Oliver. Tell me what would be the first step for you for this one?
What the first segment would I turn in x over minus 7.
X over minus 7. Is it x over minus 7 you want to say?
Sorry, x minus 7 to the minus 7 power. Sorry.
Very good. X raised to the minus 7 power, and then the second term would be what?
X to the minus 5 power over 3.
No, man. You remember I have 3's in the numerator. So go again. It would be
3x. Minus 5.
Very good. So the 3x to the minus 5.
Yeah, 3x. Yeah.
Right. So, so what it is that we're doing, we have to perform a little bit of indices first to the question, and then we work the question. So 1 over 7, because we never normally write or index as a negative power, so we're going to convert it to a negative power. So 1 over x to the 7 is the same thing as x to the negative 7. And 3 over x to the 5th. So look at my rule here, the laws of indices. Let us go back to the laws of indices. You would have done this in the associate degree for discrete mathematics. 1 over a to the positive m is going to be equal to a to the negative m. I'm finding the reciprocal of it. And similarly, if I have 1 over a to the negative m, when I reciprocate it, it's going to be equal to a to the positive m. So that's the rule that we're using. So what I'm going to have, when I rearrange, that's what I'm going to have. X to the negative 7 plus 3x to the negative 5, and then the rest of the question remains the same. You see, not difficult, AC?
Okay.
All right. All right. I give you a minute. Start for me, please. Nikki, hurry up and do the work and come out of the pot.
So I don't hear what you just said, sir.
Nikki, I don't know what is wrong with your device, You finished the first part of the question? By the way, did you get the 8x plus 3? Should go on again. All right. Talk to me now. Finish your question?
I don't think I'm finished.
Okay, continue. For original, guys.
Yes, sir.
Mm-hmm.
Get someone saying, no, sir, but many if it's correct.
Anybody else get it? Any answer? Any other answer?
Sorry, you called my name just now?
I'm saying, talk to me, guys. Talk to me.
I don't know what I said to you, sir. So here's where I stop. 7x raised to the negative 8 power minus 15x raised to the negative 6 minus 8x. Oh my God.
I see a big sir, but the signs are wrong myself, sir.
No, the same signs they may have.
Yeah, but negative 7x to the negative 8?
Oh, me never said it, sir, but may have it.
That's MC it wrong. I never hear it. That's it. Stop doubting yourselves. Nikki, you're gone. Drop a secret. Nikki, wake up.
No, sir, I am here, I am here, I am here.
Yeah, I need to hear you. All right, very good. So now I'm saying, use the chain rule to differentiate the following, because we're learning the chain rule, you know, and incidentally, it's not one rule we're learning tonight here. So I'm giving you this. Matter of fact, tell me the answer. We're not writing it. What's the answer for that?
14x minus 3.
14x.
Correct. Answer for the next one. F of x is equal to that. Matter of fact, incorrect. You will need to say dy by dx is equal to 14x minus 3. Right? F of x is equal to 2x squared plus 5x minus 3. What is the differential?
dy by dx is equal to what?
F dash of x in this case.
F dash. Oh.
Right.
Oh,
F
yeah,
dash of
yeah,
x.
yeah.
Yeah. Go again.
Cool.
Go again.
F dash of x is equal to 4x plus 5.
Hey! Move out my way.
Sorry, you're not mad.
You may need to write this one. No, you don't. No, don't write it.
No, I don't need to write.
Uh-huh.
F dash of x is equal to, let's say, no, minus 3x.
Minus 3x.
No.
No. Minus 3x what?
4. Negative 4.
Very good. Minus 3 to the negative 4. Remember, you know, it's a negative sign there. And when a minus a negative number, it apparently becomes bigger, but it's really smaller. So it's going to be negative 4. But there's something that we do. We never normally leave our power. See there? Negative 3 to the x, negative 3x to the negative 4. But we never normally leave our index as being negative. All right? We always try to write our index as a positive value.
Minus 3 over x to the 4.
Very good. I had them class I like teach. I feel like I'm a teacher. Oh crap. Sorry.
Could you share this document with us, please?
As per usual.
Okay. Like, don't forget no, sir.
No, you need to remind me.
All right.
It's supposed to be negative 3 over x, negative 3 over x to the fourth power. All right. I want to show you something here. I want to show you some consecutive. I notice I'm stopping at the third derivative because we are not required to go above the third. All right, so I want you to look at something here for me. If I gave you f of x to be equal to x to the third, x cubed, and I asked you to find the first derivative, you would agree with me that it's going to become 3x squared on.
Yeah.
And if I ask you to find the second derivative, it means that you're going to be using the first derivative to differentiate it one more time in order to get the second derivative. So what you're going to do is to differentiate 3x squared one more time. And when you differentiate 3x squared one more time, what do you get?
6x.
6x. And that is known as the second derivative. If I say to you, find the third derivative, you're going to differentiate 6x. And when you differentiate 6x, what do you get?
6.
Good. Can I ask you to find the fourth derivative?
Egg.
Egg. 0. Why comes?
Same x to the 0.
Because the differential of a constant is equal to 0. Very good. Differential of a constant is equal to 0. Excellent. Those of you who are not following, you need to get on the bandwagon and follow. It is not hard enough. But why am I encouraged? Because in recent times, teaching this aspect of it would have required a little bit more energy from my side, but my side sound bright tonight, and I love the sound of it. So I'm feeling very encouraged. So let me introduce you now to something that is called the power. So chain rule finish, you know. Chain rule finish. What is a chain rule, sir? Chain rule means that I'm going to have a function separated by positive signs and negative signs only. Something plus something minus something plus something minus something minus another something or plus something, right? And then what I'm going to do is to differentiate individual links. So the chain rule is the easiest rule in differentiation. The chain rule is the easiest rule in the differentiation. All right? Then now I'm going to move into something that is called the power rule. Now, the mere fact that it says power rule, it means that the function that is going to undergo the differentiation must have a power. So in order for me to use the power rule, it must have a power. And this power, I must say, that is going to be enclosing a minimum of 2 terms. No? It could be 1 term too. Because I could give you 3x squared, 3x all squared. Yeah.
Hold on, sir. You lost me.
No, what I'm saying to you is for the power rule, it has to be something that is raised to a power. So I was saying to you that it could be a minimum of 2 terms, but I'm also saying that I could have given you 2x all squared and asked you to differentiate it. So it don't have to be 2 terms. It could be 1 term as well. So the rule is whenever you have a term that is raised to, everything is raised to a power, then that is going to be the power rule, not 2x squared, because 2x squared is not raised to, is not all the terms that are raised to the second power. 2x squared is only saying to you that the x squared is affected by the square, or the x is affected by the square. The 2 is not. So x cubed is different from x cubed, x in parentheses and cube. It's a different format. It works out to be the same thing, but it's a different format. So what I'm saying to you, when you see the power rule, you're going to have terms in a set of parentheses being raised by a power. So watch me. I'm going to work through this one. Watch me. I'm using this 2 like I did for the chain rule, to multiply everything in front of the parentheses. So it becomes a coefficient. See it right here, so? And then I'm going to reduce this by 1, just like we did for the chain rule. So I'm going to write back my 2x plus 5 and then reduce it by 1 and call it 1. Everybody understand this so far? Everybody understand this term so far?
So far.
Yeah, man. It's the same thing that we have done. We have been doing. What I'm saying to you, let me go again. It says given y equals that, find dy by dx. Remember I said to you that sometimes the question I won't tell you anything about differentiate. See here, given y equals this, find dy by dx. So you're finding dy by dx, it suggests that you're differentiating. So I'm trying to give you other language that we possibly can use. By the way, anybody has found any more past papers? Please and thanks. We're going to need, especially for the differentiation. I just going to win the past papers and said, come, we're going to differentiate this, and that, and support and so on. So we need the past papers, all right? So let's go. So 2x plus 5 to the second power, y equals 2x plus 5 to the second power, and we're trying to find dy by dx. We are going to differentiate it just like how we differentiate it normally. We're taking the power and we're multiplying it in front of the term to make it become a coefficient. See here? So the 2 right here, so boom. And then we're reducing the power by 1. So it is now 2x plus 5 to the first power. See here, so? Boom. Then sir, this, oh, this is not decimal and then 2 or a full stop and 2. In big school, this dot means multiplication. Right, by multiply by 2. What we have to do is that we have to multiply by the differential of the parentheses. So we're going to look inside the parentheses and multiply by its differential. We're going to be looking at the parentheses and multiply by the differential. All right? So when I differentiate 2x, what do I get? Quick and fast. Come on, man. When I differentiate 2x, what do I get?
2.
2. And when I differentiate 5, what do I get?
Egg.
0.
Egg. 0. Good. So that means this is why it is only 2. So recall, times 2 is obtained from the differential of what is inside the parentheses. Times 2 is obtained from the differential of the parentheses. You will always multiply by the differential of the inside of the parentheses. So you teach a nice? I say it, I'm going to write it. You will always multiply by the differential of the inside of the parentheses. Can't go wrong if you follow my instructions. I promise you, cannot go wrong. So to use a power rule, because let me not even show you the alternative method just yet, because I have it here for you. All right? So what we're going to be doing is to
Sir?
sorry. So what we're going to be doing is to multiply the coefficient, the differential rather, of the inside of the parentheses by everything else. All right? Please note. Please note. Please note. 1, we are required to differentiate inside the parentheses. A lot of students keep forgetting this. It will make the question wrong. So if this is the start of the question, it means that the whole question is wrong. You must differentiate inside the parentheses. 2, to apply the power rule, the index must not be equal to 1. I can't use the power rule if the index is 1. To apply the power rule, the index must not be equal to 1. It has to be greater than 1. If the power is 1, I don't have a power rule. Talk to me.
Is there a third step, sir?
Oh, sorry. No.
Okay.
So what I'm saying to you is, this 2 is going to be multiplied by this 2 to give me 4. I'll see the 4 right here, so. And then I'm just going to write back this 2x plus 5. Remember, when we write something to the first power, it's the same thing. So I'm not going to put to the first power. All right? And then I'm going to multiply this over this to give me that.
So this one that we're looking at is different from the given, right? No.
No, man, it's the same. It's a continuation of the given.
So in this case, the answer would be 8x?
No.
Or the answer stops there?
What's the answer?
8x plus 20.
Thank you. Yes, ma'am. 8x plus 20 is correct. Too. Let me give you some trouble tonight.
Sir, no.
Yeah, man.
But, sir, at 9 o'clock.
No, it's not 9 o'clock yet. No, it's 9
Sir,
minutes. No, it's 9 minutes too. I have enough time. I'm going to separate the girls from the women. No, so I'm going to separate the little girls from the big girls and the little boys from the big boys. All right? Meaning, I'm going to see if it is that you're still in little school or in big school. Aha! I want you, all of you, to expand for me 2x plus 5 all square. I want you all to expand for me 2x plus 5 all square. So you have 2x plus 5 all square. It's going to be the same thing as 2x plus 5 times 2x plus 5. Work out that for me, please. And when you work it out, you're going to differentiate it using the chain rule. I want you to differentiate it using the chain rule, and we're going to compare our answers. On your mark, get set, go. When you finish, let me know. Don't just sit down there and don't let me know. Let me know.
Man up with 4x squared plus 20x plus 25.
Differentiate that for me now, Papa. Proud of you. Differentiate that for me.
Plus 20.
All right.
You're quick doing one.
Yeah, man. The man of fire.
What else a while ago?
Man say a shot.
Oh, we have good advisors, man.
Good answer. Proud of you, man.
Sir,
Yes, my love.
For Thursday, where will the test be?
Right here, sir.
So I come to class and you go project.
Ma'am.
Huh?
No, ma'am. You're gonna go to class and you're gonna log on to your Ediphosoft. Like, thanks for asking me that question because I logged on to Ediphosoft and there are only 4 of you in the class that logged on to the site. Only 4. Only 4 when I went on. The rest of you are yet to log on to Edifo. And none of the 4 that log on started any assessments.
All right, so I'm gonna log on now. See if everything will work.
Sir,
And none of you.
Sir,
Say it again.
you post any question on it?
Long time from the same day set up. Your assessments are on.
Aye, that's the one, sir.
Yeah, man. Check it, man.
Sir, we don't
Check.
see any on it, sir.
You know, see that assessment there?
No, sir.
Double check. And incidentally, just to let you know, I feel very encouraged about this group. Please do not feel me. All right, so one other person just log on, and it could be Miss. Yep, that's was her at 9:56 p.m.
Let me not tell you, sir.
Sir.
Sorry.
Yeah, who that? Yeah, say it again. Mm-hmm.
Oh, they're
Sir, I would
here.
like to talk to you after class.
Oh, wait, Talia?
Yes, sir.
Mm-hmm. Who said them those in the assessment now? Talk up.
Start
My
seeing
assessment.
them.
Oh, that's no
I
my
guess they
assessment.
don't know where to look.
Well, tell
Gentlemen,
them.
when you log to EduCasoft, on the, what is known, left-hand corner, you have assessments and tutorials tab. You can check for the tutorials and you can check for the assessments. They're there.
Yes, and all of those are found on the course tools.
Yeah, on the course tools.
Then did it. Yeah. So I have big plans for this class. You know, is a small number of you. In order for me to run a calculus 2, I need you to pass the course because I can't run a calculus with 1 student or 2 students. So I need you guys to move over to calculus 2. So when they start working, some of you are not pulling the weight so far, and you know yourself. But I believe in the group, though. 100% believe in the group. All right. So the point I'm making is I can be given a power rule, but a power rule can also be converted if I were to, expand out the power. And then I can differentiate it using my chain rule, and I'll still end up with my 8x plus 20. I'll still end up with the same thing as the 8x plus 20. All right? Now, what I'm saying to you is, if it is like what I gave you, 2x plus 5, all squares, you can't do that. But guess what? It's because the man them don't want you to do that. They're going to give you the question that say 2x plus 5 raised to the 15 power, or 2x plus 5 raised to the 10 power. Who gets it on and do? that the level of multiplication, not me. Matter of fact, even if it is raised to the third power, me not going to do that multiplication to the third power. Raise it, negative. If it is to the second power, I may give it a chance. But once it's more than 2, me not do that. So the point I'm making is you must learn your power rule. In a nutshell, you take a power, you multiply it in the front, the coefficient as a coefficient, and if a number is even there, you multiply by that number, and then you are reducing it by 1. But importantly, you are also going to be finding the differential of inside of the parentheses and multiply it out. That's all that you're doing. That's all that you're doing. All right, it's now 9 o'clock. If you look to the bottom of your screen, you'll see me about to talk about the power of the product rule, but I'll wait until, let me give you a story. The product rule is the first times the differential of the second plus the second times the differential of the first. That's all that I'm going to do with the product rule. The product rule is the first times the differentiation of the second plus the second times the differentiation of the first. Sir, I don't see differentiation, there's a differential, same difference. The first times the differential of the second plus the second times the differential of the first. Sir, what is the first, what is the second? Stay tuned for Thursday. Hey, we're now going to 3 hours for the mid-semester here. Time is against me. We're going to do the mid-semester in about an hour, and then we're going to use the other 2 hours and maybe a little break in between. But for sure, we're going to continue with teaching and
How
learning.
much questions will there be on the test, sir?
Say that again?
How much questions will there be on the test, sir?
I have no clue, but I can tell you everything we've done since September.
Sir, what can I tell that?
Good styling, man. Good styling. Good styling. So you may get a piece of everything, yeah, man, but trust me, everything that we've gotten. And that's why I spent time last time to go through the past paper questions. And to be honest with you, I feel that you guys are ready. It just means now that you need to put the tire to the road. Make it happen. Make it happen by just doing the work. Once it is that you do it, you're good to go, man. All right. Again, I had done up the copy of the notes from last time. Clearly, I saved it to my computer, but I didn't send it off to the stuff. That I apologize for. I sent it off tonight. Normally, after class at 9 o'clock, I kind of just need to just relax a little bit before I do the stuff. So I'm going to see if I can do that and then send off this one tonight. If not, I'll be can send it off tomorrow morning.
Sir, no, but I relax tonight. And just send it
I
off
forget.
and then you relax.
I think about it for me. All right. Do me a favor. Just make sure that you're doing your revision. Make sure that you're doing some practice. There are students in the class that are following, that are understanding what is happening, and I'm saying to you, you too can do the same, but if you need help, reach out to them. Reach out to me as well. Reach out to your classmates. Your classmates are very good people to do the explanation because they will explain it to you how they understand it outside of what I will say. All right? But I'm expecting you guys to all do well. Big up on yourself. We'll talk on Thursday about you.
All right, sir.
Yeah.
Have a good evening. Sir,
See you
remember
too,
to send the thing before you relax.
Okay then.
Nice.
Sir, my
All
mom
right.
wants to talk to you.
Oh yeah. Call me right now, cause I'm gonna drop us. Call me right now.
On WhatsApp, sir?
Yeah.
Okay.